Okay, let's go ahead and take a peek at this question. This is an AP question from 2003. So we've got a simple random sample of adults living in a suburb of a large city. I'm gonna move the suburb just a little bit. Okay, so the annual age and income is what we recorded. So we have age and their income, the money they make per year. The resulting data is summarized. We got a table here. So a couple things to note. We do have a few different age categories. We've got 207 people total. We've got 3 different ways that we sorted the income. And then we've got people listed in all the categories. So for part A, what is the probability that a chosen person at random from this sample will be in this age group, 31 to 45? So notice we haven't put any restrictions on income. We're just looking at the age group. So just looking at this row. So I've got 89 people out of the 207. Now to get full credit on the AP rubric, this is what it should look like. So the probability of person in 31 to 45 age group equals 89 out of 207. Now, if you want to convert this into a decimal, you can. That's fine, or you can just leave the fraction. So if I record, I had to get my calculator out. So if I record this as a decimal, I just for the fun of it, sometimes it's easier to see it this way, is 0.43 or 43%. For part B, what is the probability that a person chosen at random whose income is over 50,000? So we know we have a person whose income is in the over 50,000 group. So I'm going to switch colors here. So we know we have somebody that makes over $50,000 based on this wording. What is the chance then that they're going to be in this category or that age group? So now we're setting a condition of that you have to make over 50,000. And does that change my odds, or does that change my probability of having a 31 to 45-year-old? So we can write this with notation. So this is a conditional probability. It's a bird clock. So we have, just gonna keep going. So we've got a condition, and our condition is that the person makes over $50,000, and we want somebody that's 31 to 45. So we have 96 people that make over $50,000, and then within that, we've got 35 people that are in the age group we want. So if I write this as a decimal, 35, I'm going to get my calculator out, 35 divided by 96 is going to be 0.36. So now part C is the follow-up question. You've got 2 answers here. You have picking a person, the chance of you picking a person that's 31 to 45, and then setting the condition, does this probability change? And so the probability from here to here, when I slap the condition on there, it's less likely to get somebody in this age group once I put the condition of money on there and how much they make. So for part C, we just want to explain that. So we would say no, not independent, because I'm abbreviating here a little bit so I don't run out of space. Not independent because the chance of getting a 31 to 45-year-old will decrease when we add income. So just justifying and using the numbers up here, we've specifically said we know it's not going to be independent because the probability has decreased. So you do have to indicate how you know that, and then we know that because the probabilities are different, and specifically they went down when I slapped the money on there, slapped the condition of income.